Let's talk about this series here, which is 4n squared minus n over n to the third plus 9. This is the series going from 1 to infinity. So how in the world do we solve something like this? Well, what I want you to realize is that when you see problems like this, you need to go through a process, right? You can't just immediately jump, oh, convergence test, easy. No, it is the convergence test, but how'd you get there, right? Because on a test, you'll just see this and you won't be given context. You'll say, find convergence or divergence. That's the hardest part. You could probably do the steps really easy. It's just, how do you identify that? So you look at it and you say, I'm gonna do a divergence test first. You're gonna find that when you do the divergence test, you take the limit of the partial sums, which is this value here, right? We take this one, add it to another one, add a different n value, add it to another one, add a different n value, or the next n value, right? So we take the limit as n approaches infinity, right? So as we approach term infinity, what is that gonna be for 4n squared minus n over n to the third plus 9? Okay, you're gonna plug infinities in and you're gonna notice you get infinity over infinity. This is indeterminate. There's more work that needs to be done. So you take L'Hopital's rule, so take the derivative of the top and the bottom. So you're gonna get 8n minus 1 over 3n squared. Alrighty, you take the limit of that, do you get a determinate value? Well, no, you also get infinity over infinity. So you do, once again, L'Hopital's rule, which is going to give you 8 over 6n, which is 8 over infinity, which is just 0. Okay? Because if I have one cookie and I split up a million different bazillion ways, you're not going to have anything left. That's going to be 0. Alrighty, so the limit as n approaches infinity for this turns out to be 0. Now that's kind of a problem, alrighty, and it's a problem because when you get a thing of 0 and not a non-zero number, well, that means that this is indeterminate. It doesn't tell you anything. It doesn't tell you if it's convergent or divergent. If we would have gotten 1, 50, 5 million, 300, we would notice that this would be a divergent series, but that's just not the case here. So because of this is unfortunately going to be indeterminate by the divergence test. So that's the first thing you should always do, divergence test. Can you do it? Unless you have factorials, I mean, it's not that hard. So no, we don't really know if it's divergent or convergent yet. So we haven't determined that. Next, you should go to the integral test. Is it always positive, decreasing, continuous? But before you even do that, ask yourself, can you do an integral of this easy? Not really. I mean, if I split this up, this would be an ln, but this gets a little tricky. N to the third over n, that can get a little tricky with the math. So don't make it hard on yourself. It's kind of a complex integral to evaluate. So if we don't want to do the integral test, we can do another test. And another thing to point out, it's always positive, but is it always decreasing? You'd also have to take a derivative and find the derivative of all this and determine for sure that it's always decreasing from 1 to infinity. So that's always a pain. And you have to find continuity. So the integral test is like, wow, I mean, I guess I could, but that's just such a pain in the butt, So what I'm going to do is I'm going to make a comparison. So I'm going to say, well, I have this here. What is something that I could strip out that I could find the divergence or convergence of? Now, this is something that just takes practice and seeing the math. You have to see it to really understand it. Now, how I look at it is I say, what are constant terms? What are terms that are just there? They're not really contributing, or that I can determine easily what their effect is on the function that I can just omit. Alrighty, so I'm going to notice that 9 and negative n are doing that. However, these terms are kind of more complex. But I also notice there might be like a p-series here. Okay, if I take 4n squared over n to the third, if I omit the two constants I'm talking about, which aren't really constants, but, well, 9's a constant, but n is like adding every time. But not important. Notice here, This is 4n squared over n to the third. What can we do with that? Well, we can just simplify this to 4 over n, right? This should scream harmonic series, which is divergent, okay? So we know we found a harmonic series hidden in here. So what can we do? If we can easily say, okay, this section here is a harmonic series when you simplify it, could we make the comparison to 4n squared minus n over n third plus 9 to 4n squared over n to the third? Yeah, you'd say, yeah, I mean, you could make a relationship out of this, right? You just have to determine what all the variables are doing. If these are constant, it's literally just this over to compared to 1 is what you're comparing it to. So think about it. If we're subtracting a number from the numerator, that's decreasing the value of our fraction here, right? So this is decreasing. We're adding something that we're not adding on this side, so it's going to increase the denominator, which is going to decrease the value. So we know that this is going to be greater than this. This is a little unfortunate here, unfortunately. Kind of stupid why I'm even talking. But, you know, whenever you teach, here's something a lot of people don't understand. When you teach, you kind of just go with the flow. Unless you really have memorized what you want to say or it's a very important point, you kind of just go with the flow, which is what I'm doing now. Okay, so besides my ranting, we're going to draw this function as red. Okay, if this function is always greater than this one, well, and I know it's divergent, well, what does that really say? It doesn't say anything, right? If this function is always less, it could converge, it could diverge with the function, we don't know. So it actually turns out that this is indeterminate by the comparison test, which is kind of unfortunate, right? We can't determine by this if it's convergent or divergent. So what we have to do next is a limit comparison test. I did about 6 minutes of math and noticed I did a stupid error. So basically the only thing we're adding here is we're saying, I just rewrote our sister series, I like to call it, that we're doing a comparison to. So comparison test didn't work. Now we have to do a limit comparison test. Basically, take the limit of a fraction of your parent series over your sister series. Does it approach some value? If it doesn't approach some value, if it approaches infinity, where the limit does not exist, well, what that says is that there's no correlation between the two. But if you do get a defined value, 0 or some non-zero value, what you're going to notice is that these are linked somehow, and if one diverges, the other one diverges, or if one converges, the other one converges. So what we say is, let's take the limit as n approaches infinity for 4n squared over n to the third plus 9 all over 4 over n. Basically what we're going to do is say, okay, we can reciprocate this by saying, well, if we have 1 over 2, this is the same as saying 1 times the reciprocal of 2, which is 1/2, which we know is true. These are equal. Alrighty, so what we're allowed to do is take this and flip it and do multiplication instead. So this is like saying n over 4. Alrighty, so if this is true, then we can just multiply across to give us the limit as n approaches infinity for 4n to the third minus n squared, 4n to the third minus n squared over 4n to the third plus 9. Now, if you look at this and you're like, you can't evaluate the limit of that, that's just going to be infinity over infinity. Well, what you can do is do L'Hopital's rule a couple times. You'll find that these will just go to n to the third, or 4 to the third. But let's show that just to be thorough. This is going to be 4 times 3, 12n squared minus 2n over 12n squared. Jeez, I almost messed that up. That's insane. All right, so now we need to do L'Hopital's rule once again. 24n minus 2 over 24n. Still indeterminate when we take a limit. So let's do it once more. 24 over 24, this simplifies to 1. So our limit evaluates to just 1. And because we approach a singular value of 1 and not infinity, or the limit does not exist, well, we know these two are linked together. They're linked. So what does this tell us specifically? Well, we're going to state the following. All right, so assume a sub n is equal to this. So a sub n, we're saying, is equal to the partial sums of this series, and b sub n is equal to 4 over n. So we're making some assumptions because a sub n is less than b sub n, and the limit as n approaches infinity for a sub n over b sub n equals 1, and b sub n is divergent, and b sub n is divergent, a sub n is also divergent. So we found because b sub n is divergent, and we took a limit comparison because we found it to be a value, well, they're linked, and a sub n is also divergent. Hope this was helpful to you. If it was, please drop a like, comment, and subscribe. I greatly appreciate it, and I hope that you have a wonderful day.